Okay, we're going to talk about taps and dies and specifically what we do to clean up bolts or threaded holes when they're damaged. We use two things. One of them would be a tap, the other would be a die. The tap is made to clean up holes, threaded holes. You can see it has cutters on the outside edge, and that's what cuts and cleans up the threads. When you thread this down inside a hole, it will clean the thread grooves out of any damaged material, dirt, rust, whatever's inside, and make it so we can thread it with a bolt again. Dies are made to clean up bolts or cut threads on rods. So they're used for two different things. The tap will be used to cut and clean up holes, threads in holes. A die would be used to clean up a bolt that was damaged. There's two types of sets when we talk about tap and dies. One's the traditional tap and die set. That's what most people think of when they think of tap and die sets or taps and dies. It comes with a variety of tools in it, a variety of tap sizes, tap wrenches. It also may contain a thread pitch gauge, such as this one does. The other thing that you may see that some technicians have is a rethreading set. The rethreading set is similar to a tap and die set, but it's really used to clean threads only. It's not meant to cut threads on something that doesn't already have them. So these threads are made to clean up or clean up threads instead of cut threads, so which is advantageous when you don't want to take any more metal off to repair the thread than you have to. So it's really good. A lot of technicians have those. Many of these kits will also include thread files. You can see this thread file at the bottom. There's two of them, a metric and a standard one, and they are used to clean threads up also, and we'll talk about that in a later slide later on in this PowerPoint video. So tap and die sets and rethreading sets, we use them to clean, both of them to clean up threads. Tap and die sets can actually cut the threads and repair really severely damaged threads if possible. So this is a tap. It's used to cut threads in a drilled hole. Like I said earlier, you can see the cutter ridges on the outside. When we go and start this, it's tapered on the bottom to start in a hole. Once we get it started, if we start it straight, it'll grip into the threads that are already there and clean up the threads and any material that's damaged or in the thread grooves. It's usually used when we already to clean up threads in a already threaded hole in our industry. Again, if we had something we wanted to drill and tap, that would mean drilling a bare hole and then using this to put threads in the hole. We could do that out as well. Taps also usually have their size on them. This is an 18 millimeter by 1.5 tap. We'll talk about that in some later slides on how to identify tap and die sizes. To turn the tap, use a variety of tap wrenches. On the right you can see several different tap wrenches in different sizes and different types. You can also use wrenches and sockets to turn them. If you look over here, you'll notice there's a hex shape or square shape on the end of the tap. A small wrench or a socket can be placed on that to turn a tap in tight spaces. So you don't necessarily have to use a tap wrench. Sometimes a tap wrench, these handles that stick out, may be in the way and hit something. So sometimes we may need to stick a socket, an extension on a tap, and use it when we can't get to it with the tap wrench. There's three types of taps: a bottoming tap, a plug tap, and a taper tap. Bottoming is used to clean a lot of threads. It's used on holes that are threaded all the way through. Plug tap's probably one of the more common that we see in sets. It is tapered at the end, but it only has a few tapers to help you start it in a hole that already has threads. So we use this plug tap a lot to clean things up. Do realize if you're cutting threads with it, it won't form the last 3 or 4 threads in a hole. So you'll have threads all the way down, but the bottom of the hole you won't be able to run a bolt in because those threads will be tapered at the bottom. And speaking of tapered, a taper tap. Taper taps are extremely tapered over on this end. They're made for cutting threads where there weren't threads before. So this is used when cutting a lot of new threads. It starts slowly, makes it easier to cut in as it cuts slowly a little at a time, and as you thread it in, it creates the threads. It does leave quite a few, if you're using it on a blind hole, unformed threads at the bottom. So probably not a great use. It may be what you start with, and then you may use one of the other taps to kind of finish the job. On the left over here you can see I've got pictures of them. You can kind of see the taper on the end and the differences on the taper tap, the plug tap, and the bottom. Again, bottom's pretty good for cleaning things up. That's a type of tap that you would see used when you already have threads. We probably see the plug tap more than anything. If you're going to cut in a machine tool or a machine shop and you're going to cut threads, you may have a tapered tap at the top and use it more often. Size of taps. Taps have several sizes on them, and the sizes are usually determined by 2 things. The first is diameter and the second is pitch. If you remember from our PowerPoint video on bolts and nuts, we talked about the differences in sizes of bolts and nuts. 2 of the things that we used to determine the size of a bolt or nut was the diameter and the pitch. If you look at this diameter, that will usually be on a tap. This is a metric tap, and it is a 7 millimeter, and the thread pitch is 0.5. So this metric tap is an M7 by, which is what the X stands for, 0.5, which is a thread pitch, or a 7 by 0.5 tap. When we move over to the standard tap, you'll see it's in a fraction, 5/8. That is the diameter of the tap. The 24 that you see is going to be the threads per inch. So this tap would be a 5/8 by 24 thread pitch. That means it's got 24 threads per inch. So we have a 5/8 24 tap. On this side we have a 7 by 0.5 tap. Just going over some different sizes of taps. On the left you'll see the metric tap sizes. There are several. They go way on up to large sizes. These are the sizes we deal with most often, and there's a few odd sizes like a 9 millimeter and an 11 millimeter that we see sometimes in the automotive industry. So these are your standard tap sizes. You may see some other sizes in there as well occasionally. On this side you'll see SAE, and SAE is again diameter and pitch. 5/16 diameter and the pitch would be 18, so this is 5/16 18 die. This is a coarse die, so it's national coarse. And if you notice, like a 5/16 18, we also have a 5/16 24 threads per inch. That's a lot more threads per inch than the 18, even though these bolts are still 5/16 in diameter. So this is national fine, this is national coarse. The only difference between national coarse and national fine are the threads per inch. So we have a 3/8/16. The fine will have more threads per inch. As you can see, this one is a 3/8 by 24, and they all kind of correlate and go along with that. So When we're looking about pipe threads, we talk about British Standard pipe and National pipe tapered. If you look on some of these taps, they will tell you NPT or BSP. Same thing goes when we're talking about dies. You'll see these sizes on the tap or on the die. And a pipe tap, a lot of times that we deal with in the automotive industry, you'll notice is tapered. It has a slant to it. So when you talk about a pipe tap, a lot of times it's tapered, and that's so that the plug that threads in will basically bind up in the threads, and the plug will actually seal against the threads when it binds up. So you'll notice that pipe plugs, they kind of bind up without being threaded all the way in. That's because the hole isn't threaded all the way through. It's kind of on a taper. So, using a tap, we try to do it with a wrench or a socket or a tap wrench, whatever we can. You want to turn it a half a turn to a quarter turn at a time. Reason we do that is we want to go slow. We're taking metal off. We're actually removing metal, so we want to go slow. But it's also, once we get that quarter to a half a turn at a time, we'll want to reverse direction and move the tap back about a half to a quarter turn. If you look at this flute, this little hollow area in the tap, as I turn this tap in the hole, these cutters are basically cleaning junk and rust and metal out of the thread hole. If it's damaged metal that's been mashed into the thread groove, it's going to cut that out. So when we turn it in and cut it, we'll want to go back a little bit to break those off so that they can fall down and fall out along the flute. So always remember to turn a half to a quarter turn at a time, and then to reverse and clear out metal chips, and you'll feel them break off when you reverse it. So, and like always, lube it as needed. You'll kind of be able to tell if you need to lube it or not. Talking about dies. Dies come in several different flavors. A couple of the most common are hex and round. They're used to cut external threads on a solid rod, or in our case, we use them a lot to clean up external threads on an existing threaded rod or bolt. So we'll take the die and thread it down onto the bolt and let these cutters inside clean out the thread grooves on the bolt. And again, there's two types, a hex die and a round die. We call it a hexagonal and round. So those are two types, and there's more than that, but those are two pretty common types we see in the automotive industry. Sizes of dies, just like the taps, the sizes are usually on the die. If you look at a die, it's going to be in the same two measurements that we use for the taps, and the same two measurements that are used to determine bolt size. We're going to use diameter, and we're going to use pitch, thread pitch. So if we look at this die, it's a fraction, so it's a standard die, and it's 5/16 of an inch. That's the diameter across of this die. It's 5/16 of an inch from this edge to this edge. So it's a 5/16 diameter thread, and it's 24 threads per inch, and that tells you how fine the threads are or coarse the threads are. So we need to make sure that we match the thread pitch and we match the diameter to make sure that when we use it, we're not doing more harm than good when we're trying to clean up a bolt. If you look on the metric die over here, you can see it's a metric 14 by 2. X means by, so 14 by 2. When we talk about 2, that's one of the thread pitches, and that means there is 2 millimeters between the threads. So if you remember from our nut and bolt video PowerPoint, you'll remember what that means and what that 2 millimeter means as far as thread pitch. Common sizes for metric will be 1.25, 1.5, 2 is rather large, and you'll see 1.75 is another common one. So this die is an M, which stands for metric, and it's a 14 by 2 die. This die is a standard, and it's a 5/16 by 24. We use die wrenches to turn dies, just like we have a tap wrench for a tap. There's lots of different types. There's usually a different wrench for the hex dies and a different wrench for the round dies. You can also use a socket or a wrench or whatever you can get on this hex die to turn it. If it's a round die, such as this one, you're probably going to be stuck with trying to use a special wrench, die wrench. So you can use sockets, you can wrenches on the hex dies. They're more versatile. That's why I like those and prefer those. They also don't have as many problems with spinning inside the wrench. Using a die, there's usually going to be one side that's tapered. You start that side first. Sometimes it says start this side first. So when you start it, you're going to thread the die onto the bolt. You're going to turn it slowly, just like we did for the taps, a quarter to a half a turn at a time. And just like we did for the taps, we're going to reverse direction a quarter to a half a turn to clear any accumulated chips that come off. If we're threading, cutting threads, there's going to be quite a bit of metal removed from this rod, this solid rod. Those little metal pieces are kind of peeled up, and we need to reverse direction to break them off so that they can fall out and fall down out of the way and not bind up our die as we turn it. If we just kept turning this without backing it up, eventually it would bog down and be hard to turn. So makes much better threads, much cleaner threads if we back it up in reverse direction, about a quarter to a half a turn for every quarter to a half turn we take. And as always, oil or lubricate as needed. Finding the right size. Finding the right size is a problem, and it's just like finding the size of a bolt. We use diameter and we use thread pitch. The easiest way to tell diameter is to measure it with a dial caliper and determine whether it's a metric size or a standard size. And the thread pitch, the easiest way is to use a thread pitch gauge, such as this one. You can also use a tap. You can see here a tap has sizes on it, so you can pick up several taps and compare them to the bolt you're using, and you can see which one matches up. So when you lay the threads onto the threads of a tap, they should match if they're the same size. And again, if you're using a nut, you're pretty much stuck with a thread gauge, or looking at it and trying to guess. Some people can look at it and guess pretty good what size to use. If threads aren't damaged too bad, you can use something called a thread file. The thread file has usually 4 sides, and the 4 sides have little ridges like this corresponding to the thread pitch. And when you run them through the thread grooves, they basically act as a file and just knock stuff out of the thread grooves. So you're going to match it up with your bolt, and you're going to run this file back and forth across the bolt threads and let it knock anything out or file anything out that's in between the thread grooves. You have to make sure you're using the right size. This top size is a 2 millimeter, so it's a metric. On this size, it's a 1.5 millimeter. I'm sure they have a 1.2, 5, and some other sizes. So make sure you use the right size, right thread pitch, and you basically just stick it in the grooves and run it back and forth. You can see this one, how it's fitting perfectly in the grooves, and they're just going to move that back and forth to clean out the threads, which works pretty good if they're not damaged too much, or if you don't have the right size tap or die for situation. So if the hole or the bolt is damaged too badly, you're pretty much regulated to replacing the bolt if it's a bolt, or if it's a hole, you may have to put a thread insert. If you can't clean the threads up in the hole enough that a bolt will hold and grip, you're probably going to be left with drilling the hole out and putting a thread insert inside. So if I put a thread insert inside, the way I do that is I drill out the hole bigger than it normally was. You can see a bolt going down in here isn't as big as the hole they drilled. So we're going to drill out the hole with a bigger drill bit. We're going to use a special tap, and I stress this is a special tap that's going to go in and cut threads for our insert. Notice that the threads it cuts for the insert are much wider than the threads made for the bolt to go in the hole. So a 3/8 bolt will have a tap, helicoil tap, that cuts much wider threads because it's actually cutting threads for the insert, not a bolt. And once you get the threads cut with the tap, you'll use this tool, which is a insert tool, the helicoil threads on the end of it, and you turn this in and thread it down into the hole. Once you get it in the hole, you'll knock this tang out of it. And we have a really good video on YouTube that explains how to use or how to put in a helicoil thread insert if you want to watch it. Want to stress, helicoil insert or taps are not the same as a regular tap. A helicoil tap is bigger. If you look at these taps, they say helicoil on them. All three of these do, and you can see it's written different ways, but they all say helicoil. If it's a ThreadCert or TimeCert brand, it'll probably have something dealing with that brand on it. The key thing is that it is not a regular tap. If you look at this 3/8x16 tap, you'll notice the threads are much bigger than the body of the tap. So the threads are extending way out from the body. If you look at this 3/8x16 tap over on this side, you'll notice this is a regular tap, and you'll notice how the threads are actually smaller than the body. This body and this body on this tap are probably the same size. What's different is this helicoil is much bigger because it's not cutting threads for a bolt, it's cutting threads for the helicoil insert that repairs a 3/8x16 bolt hole. So you have to make sure when you're picking up taps that you find one that says helicoil, that you do not use that unless you're using an insert or installing an insert. Likewise, I can't use this tap to install a helicoil insert. So just remember that. You can see the difference in them. They're usually quite a bit of difference in size. So look on it, see what it says, make sure you use a helicoil for a helicoil and a regular tap when you're tapping a regular hole. How to repair threads with a helicoil insert, you can find that video on our YouTube site, our YouTube channel. It's a really good video. I suggest you watch it, and if you're in my class, that is one of the things you'll have to watch before you do one of your hands-on job sheets. So, it's a good video, and it explains how to install a helicoil insert. That's the end of this video PowerPoint. Thank you. This is brought to you by the Tennessee College of Applied Technology. We're in Livingston, Tennessee. Like us on Facebook at TCAT AutoTech.